today we have our another new episode, and this episode is very, very important, and we have all of the world famous speakers: Dr. Eric Dew, Professor Edward, Professor David Smith, Mr. Donalds, David Schumacher, James Ead, Mr. Rob, Shourov, and Jason. Thank you for joining today. And according to our pop plan, always I said that we want to create a more good example, and our speakers always a good inspiration for the youth community for the Asia Pacific, because the more they get a valuable speakers and valuable information, they can train themselves, they can develop themselves, and they can set their objectives. So we will discuss on artificial intelligence and robotics. Even in Asia Pacific, this December we have a mega summit, 10,000 corporations actually joining this AI related summit, and World Talent Economy Forum actually collaborating with this summit. And hopefully all of our speakers also get chance to join in this summit, even if it's online or offline. So we have a plan to move with the local corporation as well as academia, and hopefully we can make a really impactful discussion for today. And we will distribute these things almost 2,000 organizations. Already our team actually day and night they are working, and we are getting a very good support from different developing nations, and they are really happy to see different kind of topic and different speakers contribution. So I want to give a special thanks to our speakers. I want to start from Dr. Eric Dew. How do you want to analyze today's topic, artificial intelligence and robotics? And if you give us some good example of new innovations, new startup for our youth community, for our policymakers.
Well, there are so robots are just the next generation of mechanical technology, assembly lines that Henry Ford used to build his Model T Fords and such have just basically advanced over time, and now robots are just the next generation. They're smaller. Some of them are nano size, right? I mean, they're so small that they can be placed inside the body to do certain things. But it's just variations on that theme of mechanical devices. AI is the variation on a theme of calculating and computing, and more, the analogy of the mind versus the analogy of the body. So robots analogizes the body, and AI analogizes the mind. So that's all it really is. The key thing that needs to be done is there's two things. One is the freedom to allow people to be creative and to play around with it and test out different things and see where they can go with it. If governments and other entities are too restrictive, then you're missing out on possibility of somebody doing something that's tremendous. You just lose that opportunity by being overly restrictive. At the same time, the flip side is that the government and other entities have to be responsive when misuse and abuse occurs. This is a whole new world that we're creating. This is a whole new, disruptive situation that we're creating. And we don't know where it goes. We don't know where things may be hurtful to people, harmful, and the harm may not be something that's immediate. It may not be like a robot hitting a human being and knocking them down and killing them. It could be something that could take decades before the harm is manifested. And these are things that people have to watch over and see. And it takes time to monitor all this. And after it is realized that some harm may be occurring, then proper legislation has to be enacted to curb that. But it has to be done reactively. Okay, you can't prohibit it, proactively do it, because how do you know, right? So yes, some harms may have to occur before the legislation can be created to deal with it. Very much like how we dealt with automobiles. When automobiles were created, nobody knew, what possible harms that could be, and then we know that the various harms are, unsafe driving, drunk driving, the exhaust is, causes global warming and all these other stuff. So all these things that come out over time, and then we write legislations to deal with it. And that's how, that's the natural order of things. So that's really what we have to do, and we have to apply it in that order. And that's really it, as far as I can tell you.
Thank you, Professor Edward.
Well, yeah, this is a fascinating and big topic, and we could spend hours talking about it. But I want to make really kind of 2 points. First of all, I want to make a couple of points about robots. Robots indeed perform human tasks. And my message to everybody listening in the Asian Pacific area is don't fear the robots. There's a fear of technology that goes back to the beginning of the Industrial Revolution. The Luddites smashed machines because, oh my gosh, there's some women in a work shop making shirts, and they're going to be replaced by machines, and we're all going to be unemployed, and it's going to be absolutely terrible. Karl Marx's whole philosophy or whole economics is based on, the more we have automated production, the more we have efficiency, the worse it's going to be for people unless the government essentially owns everything. This fear still goes on today. I'm going to quote a few headlines here from newspapers, okay? These are major newspapers in the West. Amazon is going to kill more American jobs than did China. Robots could steal 40% of U.S. jobs by 2030. Within 20 years, automation will take the place of about 5.1 trillion per year in labor, with more than 98% going to those who are already multimillionaires. America's retailers are closing stores faster than ever because of robots, et cetera, et cetera. I could go down these scare headlines you see every single day, and they just reflect the kind of fears that went on 200 years ago. The point is that it's because of automation and industrialization, and robots are simply another version of that caused us to be so rich and prosperous, to create a huge middle class and so forth. So please, if you're listening to me, don't fear the robots, but let the entrepreneurs lead the way in determining how robots are applied. That's already happening. I mean, in auto plants for 40 years or so or more, they've had robotics, and a number of the other speakers, I'm sure, can speak at the incredible details. The other thing is concerning artificial intelligence. Artificial intelligence, of course, is, as Erica suggests, that's the thinking part. And artificial intelligence is already, for example, making scientific discoveries. The Watson supercomputer has scanned thousands and thousands of MRIs. It can make diagnosis of patients as good as teams of doctors, and even better, it's actually making discoveries of links that doctors and researchers didn't see, saying, oh, look, this and this. Isn't that incredible? Artificial intelligence I see as being at the center of a real healthcare system rather than a sick care system, monitoring people who have wearable diagnostics in real time. It's the potential of artificial intelligence is incredible. But again, I want to offer one warning to those listening. Be very careful about governments running artificial intelligence. Governments should pave the way. Governments should basically allow for experimentation and entrepreneurs and so forth, but be a little bit careful. Use the artificial intelligence as advisors, so to speak. Use the artificial intelligence for input and so forth, but be careful about ceding power to them. I'm not one of these people who worry about the science fiction views that an AI is going to rule us and is going to be malevolent. I just don't see that as the way it's going to happen. But I do see a little bit of a danger of relying too much on artificial intelligence in governance, because I think the unit of the moral unit is the individual. It's me, and dealing with you all on the basis of mutual consent. So be a little bit careful, just a little bit careful about where you put artificial intelligence into this mix with government. And those are my my thoughts.
Thank you. Professor David Smith.
Mute.
Fantastic topic. Really fantastic topic. It's interesting to me as you begin to parse it as each of the other speakers have so far. You know, one of the things good about robots is that they're excellent at performing repetitive tasks. You know, and it's interesting. We think of robots doing that in manufacturing, but robots actually can do a lot of that when you even see things in the financial industry and others of doing those those repetitive tasks. What marrying AI with robots solves one of the problems you saw in the early robots, particularly in auto manufacturing and others, is you had to sit down and program it for slight variations. And it was a manual process to do that type of programming. Throwing AI, machine learning, machine vision, and others into that dramatically changes how active robots can be. It's also very interesting to kind of see what the market dynamics are for that. One of the interesting market dynamics on that is one of the market studies on it believes that by 2023 that there will be $12.5 billion of AI enhanced robots going, and that whole market on that one has almost a 30% compounded annual growth rate. So as you're looking at that, it's one that is going to be here for a while. It's going to continue to accelerate. But some of the biggest impacts of AI and robotics come in fields that are non-intuitive. One of the fastest growing markets for robots using AI is in the agriculture industry and farming. And you begin to see how much that can really begin to optimize it. You're beginning to see robots functioning with AI and with chat bots as virtual assistants. And again, a field that I wouldn't necessarily talk about unless I go back to the Jetsons or the TV series on there. You're seeing them in retail, shopping, the whole fashion industry. You know, one of those that really surprised me recently is you're seeing them a lot in the aerospace industry. You know, it was just announced, a week ago, 2 weeks ago, that an unmanned drone, which a drone is a robot really, as it meets the definition, an unmanned drone successfully refueled a fighter jet. And most of that was using the AI built into the drone, because the reaction time, if I was piloting that remotely versus doing the refueling, isn't quite fast enough because of the latency and lag time you have there. So we're beginning to see robots mated with AI, particularly machine vision, particularly machine learning, in many, many different areas. And I think, as I said earlier, the greatest application of robots and AI are going to be in fields that are not the ones you would immediately expect.
Thank you. Thank you. Mr. Rob.
Okay. So a couple changes have happened recently in robotics as the industry was looking at this market, and Dell actually had an event, I think 3-4 years ago, where they argued that robotics was going to be the next big industrial area of growth. What's fascinating is the Dell executives seem to not attend the meeting because Dell's doing nothing in robotics. Other companies are, but the argument was that we've reached a turning point in robotic development, and that we are now able to use these robots much more successfully in a variety of areas. The pandemic really drove home the issue that automated systems, of course, are not vulnerable to sickness, and you can keep operations that would otherwise be shut down operating if you put in robots. And a lot of the development suddenly shifted to areas like food preparation, that weren't cost effective before the pandemic, but it became a difference between whether you can be open or closed. And the end result is suddenly the robots became far more palatable. because you were fixing a very real problem. So with the pandemic, I think across the board has moved up a lot of efforts by about 5 years, best estimate, and robots are one of them. And when you add artificial intelligence to robots, you get something kind of interesting. You get autonomous robots, and the difficulty, of course, is when you start rushing towards autonomous anything, training becomes your problem to solve. We've got actuators. We can physically and have been physically building robots for decades, and they're used pretty heavily in manufacturing and have been for some time. But as Tesla showcased, just automating and putting in robots isn't necessarily a good thing if you don't know what it is you're doing, and their quality control and production levels, instead of being through the roof, were problematic as they came to market because the people that were putting the factories together didn't understand automotive technology. And so when they were applying the robots to the assembly lines, the end result was subsatisfactory quality. Their quality was pretty bad, even though the cars were effectively built like tanks. The issue was they were often incomplete, poorly built, and the measurements of quality they were missing rather badly. And still, we go back to the big problem when you're building robots at scale, which is training. If you have to take every robot through and physically train it to do things, that takes an awful lot of time. And sadly, that's kind of how we started with robots. But on a manufacturing line, it's highly repetitive work, and it wasn't that problematic. But when you get to autonomy, the training up becomes far more difficult. And so the industry moved to using simulation. The advantage of simulation was that you could train these machines at machine speeds. And we really brought it forward for autonomous cars, which is really where an awful lot of the work on autonomy has been going on. AI and autonomy with regard to robots has been going for the last couple of decades. Is this idea we're going to have automobiles that will drive themselves with a value proposition of saving tens of thousands of lives every year. But there's a lot of discussion about how much control the driver retains, whether there's even a steering wheel in the car. Testing showcased that I think it was Intel that did the test, that people were actually more concerned when you put a steering wheel in an autonomous car than if you didn't, because they felt like they were going to have to suddenly step in for a robot that was underperforming, and it wasn't going to end well. In fact, a lot of the early trials showcased it really wasn't going to end well. The initial plan for autonomous cars was that if the robot ran into a problem, it would immediately turn control over to the driver, who might be sleeping, who might be reading, who might be watching a movie, and give you about a half a second to scream before you slammed into whatever it was the robot couldn't avoid. And they decided that probably wasn't a good idea, because if the robot couldn't handle it, if the autonomous robot couldn't handle it at machine speeds, it was really unlikely that a human was going to be able to step in as rapidly and save the car. But that's created kind of a conundrum, and that conundrum is in cars was liability. If an autonomous car hits somebody else, who is liable? As long as the driver has some control, it's easy. It's the driver that's liable. But as you take control away from the driver, then to a certain extent, you could argue that the manufacturer now has liability. And this liability problem has created a huge issue with regard to things like interfacing with smart cities, because cities have said, hey, if our stuff screws up and the lights don't communicate properly, and an autonomous car runs a red light and kills somebody, we don't want that liability. So we're not going to let the stoplights talk to the cars. Except if the stoplights don't talk to the cars, and the cars don't, for whatever reason, see the stoplight, you're still going to have a dead person. The only difference is okay, you can't sue the city now. You're going to find somebody else to sue, and the goal should be, hey, maybe less dead people. So we kind of lose our edge here. And then as we ran into simulations, we also discovered something that was, if you use game simulations, which was a lot of the basis for some of the early simulations, the robots couldn't make a distinction. So for instance, one of the early trials with autonomous factory robots was using a game simulation, and the robots were randomly reorienting themselves and going the long way around to a lot of things until they did the post-analysis, and it turned out the robots were seeing shadows as solid objects. And so certain times during the day, the shadows were cutting across their track, their progress, and those robots would look at that like it was a wall and go all the way around the building to approach their goal on the other side. Not very efficient. And so the latest thing is to go to full digital twins, which is and using something like NVIDIA's Omniverse, which creates a full artificial world that you can train robots in. And and this is kind of fascinating because now, in fact, just this week they announced an NVIDIA Isaac Sim, which is a simulation specifically created to train robots. And in this case, you can adjust the sim for the number of cameras that you have. You can build the robot any way you want, and then you can test it in what is a real world environment. And you can throw everything you want at the robot: lighting conditions, weather conditions, earthquakes. I was thinking it might be fun to use zombies or alien attacks, but the thing is, it's actually getting kind of fun, and I think this is a great on-road to getting students to learn about programming robots and training robots, is using something like Isaac Sim, but using it in a game scenario. So you're pitting robots against environments, maybe pitting robots against each other, but whatever it is you're teaching kids or people that want to retrain how to train these robots, because that's kind of a critical path right now to developing autonomous robots that can do a variety of things. They can navigate through reality, not run into things, perform a variety of tasks, and be able to intelligently determine how to solve particular problems. You need this, and you need people that can do it. And so we're reaching the point where this stuff is becoming a lot more fun than it was. And you could build a game-based training situation into one of these simulation environments and bring people forward and have it be a ton of fun while they're doing it. So we've advanced a lot. Another mention was with regard to robots and jobs and whether they will take away jobs, and they most certainly will. The thing is, they'll add jobs as well. We're going to hurt during the transition, though. We are really lousy at retraining people before an event occurs. And so typically what happens is you get an influx, you have a lot of jobs open up where you don't have the people to do them, and you have a lot of jobs go away where people really need to be trained. And we're really at the place right now where we should be aggressively looking at some segments and starting to train people. Here in the US, one of the troubling aspects is for robotic trucks for long haul. Right now we're around 300,000 drivers short of what we need for long haul truck drivers, and we're losing them a lot. And we're paying better than $80,000 a year with good benefits. It's just the job truly sucks. With the union, the truck drivers union is absolutely against autonomous driving. And the reality is that we would have to retrain the drivers to be more like pursers. You can get a driver for every 2 or 3 trucks that are going because they're autonomous. The driver then can do other work while the truck is driving because it's autonomous, but they're really not a driver anymore. But the job can be much more interesting because they can do other things while the truck is going. You still do need somebody with trucks, because testing has showcased that if you're all autonomous, what will happen is people will force the trucks off the road and rob them. And so you need them at the very least for security. And also because we haven't fully automated the ingress and exit of the material in the trucks, somebody still needs to manage that physically. That'll get fixed maybe in the next decade or so, but we're quite a ways off from being able to actually handle the loading and unloading of trucks fully autonomously and track the load the way we would like it. We can build the capability, but we're just not there yet. So a lot of changes, a lot of opportunity for just great games and educational opportunities to train people against this opening of new jobs, to train robots, develop robots, to take us to this next generation. And I think we're a bit behind.
Mm-hmm. Thank you, Mr. Jamsit.
Thank you, Sharif. Wonderful topic. I really appreciate what the panelists have said so far. And I really like the way Dr. Eric started us out. AI, the mind, robotics, the body. There's elegance to the simplicity. It's like E equals MC squared. Something that's that simple can mean so much. And if it helps me frame the entire topic, to think of it that way. And with that in mind, if we do not control the if we do not respond appropriately to the impending climate disaster, we may be facing things like, hey, I can't breathe the air anymore, so let me have an artificial lung. Sharif, I don't like talking with the display, so I'll stop talking until that's gone.
Okay, okay, you finish it.
Thank you. So what I think is that you know, we could start with our lungs. We can have artificial lungs, and then we can't drink the poisoned water anymore, so we'll have artificial throats, and we'll have artificial voice boxes, and the AI will come in and say, oh, okay, Jim's voice box sounds like an Irish guy, and maybe Donald will pick Finnish, and maybe Edward will pick Estonian, and we'll have some choice in the matter, but we're not, and then we can't see in the environment anymore, so we replace our eyes. We're not Homo sapiens anymore. We're Homo Robotics. And so, this, we won't become extinct, but we will become very different. It's a conceited view to think that Homo sapiens will continue. And, we will evolve, we will adapt, but it's kind of scary the way we're going to adapt. And, we talked a little bit about the scare tactics that are used. Don't be afraid of the robotics. I would say don't be afraid at all. But, be aware that the scare tactics are also like immigrations. Immigrants are coming to take your jobs. Well, the United Auto Workers are not those jobs are not being taken by immigrants. Immigrants are doing jobs you wouldn't do, starting businesses you wouldn't start. So don't be afraid, period. We have to face the future with confidence, and we will survive this one way or the other. We may not look like we look now, and lots of things might change that are pretty unsettling to think about. But don't give in to fear. Fear always leads to poor decision making. So I wanted to talk a little bit about also it's a false dichotomy to put government versus entrepreneurs. You need to use the appropriate technology. Some things the entrepreneur does, something the government has to do. And when they get in each other's way, that's a problem. But let's face it, we need both. And entrepreneurs are not angels. Someone with an entrepreneurial spirit will be stealing your identity today and taking your money. And this is not something we need. We need to have them face consequences, and only the government will provide those consequences. As Eric started us off in the conversation, we're going to be always behind the curve. The thieves and the rotten apples will always be one step ahead. But we have to kind of follow along and clean up the messes that they create. And some of them are unintentional. Some of them will be very intentional. So we have to be open-minded and open-eyed as well. So I want to talk a little bit about AI in the world of chess, because when I started playing, I became a chess master, and the computer programs were terrible. They were laughable, and they were a joke in the chess community. And this is the 1980s. By the end of the 1990s, a computer was able to defeat the world champion. And what was the struggle in the 70s and 80s, getting them to play reasonable chess? They were trying to get heuristics, to get them to think like a human being. And they took a different approach based on speed, number crunching. And it could only happen when the technology got so good that the speed of the calculations was so far, unimaginably far ahead of their predecessors. And they got so good that they could defeat the world champion. Now, is this something to be scared of? Boy, the chess community sure didn't like it. But, it's reality. We faced it. Now, we don't analyze our games together. We let the computer programs, the computer engines do it for us. And instead of saying, hey, that's a pretty good move, it's a little better than this move, now we say it's 0.4 better. What does that mean? I don't know. It's beyond me. I'm behind the times. But anyways, these things happen. Now we have Alpha Zero, what we call Alpha Zero. Alpha Zero teaches itself to play chess. Human beings don't program Alpha, they program parts of Alpha Zero, but Alpha Zero taught Alpha Zero to play chess. and to play it better than any computer programmer or program in the past. So this is a brand new world. Don't face it with fear. Face it with acceptance. The world is changing, and the pace of change is accelerating. So we can't live in yesterday's world. We have to be open to change, and don't be afraid. Thanks, Sharif. Wonderful discussion.
Thank you. Thank you. Thank you. Mr. David Schumacher.
Yeah, hello, Sharif. Yes, everyone's right. It is a wonderful discussion, and I like all the background and so forth that's been brought into this. We've talked about politics. We've talked about entrepreneurship. We've talked about the current state of AI and robotics. We've talked a little bit about fear and things that change bring to us, the human animal. You know, we, for our survival instincts, I suppose, look at fear first before we look at the positive aspects of things. Maybe that's what motivated the Luddites that were mentioned. So in that regard, I want to go in a different direction. I want to talk about the excitement that I see out of all of this as we move forward. Because I think excitement is what drives entrepreneurs, it's what drives markets, and governments you might not think of being too exciting, but then they need to react to all of this, which has been pointed out, because legislation typically is reactive. So where's the excitement here? Well, I could look at 2050 or I could look at 2030 for excitement. I like to look at the future. But I think for today, where I want to look at is the current state and the very near future of AI and robotics. So some of this is very common to us now. We don't even think of it as AI and robotics coming to us. Somebody mentioned personal assistance. And the last time we talked about this show on the road, last time we talked about this show here, I talked about how assistance in like a call center where you call in for technical help and so forth. And this call center provides information to the person that's working with you to be able to do a better job of troubleshooting your problem, documenting the solutions to the problems, and to be able to do so many more things. So I think that's an example of the excitement. The excitement is the collaboration that we're going to see between humans and AI and robotics. Instead of thinking of AI and robotics as something different from us, I think it really helps to frame this by seeing that AI and robotics are an extension of us. It was talked about that in manufacturing, robots have been used now for decades, and there are still humans involved in that manufacturing process. You can look online and see pictures of what it looks like on these automobile assembly lines, and you'll see robots that are fenced and literally caged away from the humans so that they can work safely together. What you have to look a little deeper for is where I see robotics going in many industries, which is something called cobots, or collaborative robotics along with intelligence. And that puts this triad back in place that I talked about, with humans at the apex and robotics and AI on the sides of this triangle working together, because now we can solve problems together. We can let robotics do the repetitive and dangerous parts of the process, where the human maintains control and takes information from AI. We've talked about the aircraft industry briefly. And in the aircraft industry, over my 25-year Air Force career, I saw quite a change in how robotics and AI, we didn't use those terms at the time, but how they integrated into jets, where everything was mechanical. When you move the surface or control inside an aircraft, it moved a physical surface on the outside. That doesn't happen anymore. That's all controlled by if you will, robotics and AI. You put input into the controls inside the aircraft. It goes through a computational process to determine what is the best way to control the elements on the outside of the aircraft for what it is that you're doing. And there's this triad combination right there in the cockpit to make this high performance Air Force jet do what it needs to do. Over the weekend, I'm a nerd. I sat and watched for hours a spacewalk on the International Space Station. So here are humans in a very hostile environment that have equipment that's on them that's keeping them alive as they are outside of the International Space Station. They have a robotic arm that can move equipment into place for them so that they can place it and adjust it. We have people on the ground that essentially are holding the checklist saying, here's the next step that we're going to do. Guess how that checklist is put together? Guess how that checklist is presented? It's presented from information that's been derived and distilled for that person to be able to read and then to work in combination with the humans in space. Fascinating, just simply fascinating. So that's all part of my excitement. But excitement can carry you away, and there's dangers to excitement that we need to be careful of as well. So we talk about fear, we talk about the counterbalance to excitement. What's that lever, what's that fulcrum that balances this? And I think that's trust. So developing trust is an important aspect in this. I'll briefly go back to the Air Force jets example. The Air Force had a fighter bomber, the FB-111. The F-111 was the generic version of that. And when it first came out, it had a ground following radar that was so superior to anything that had been used by pilots in the past that the pilots didn't trust it. Now, imagine a ground following radar where you're going over a flat desert and approaching a high hill or a ridge. The idea of the ground following radar in a combat aircraft is to hug the ground and to hug the terrain as tightly as possible so that you can't be seen visually, and it makes it harder to be seen electronically by the opposing forces. So this FB-111's radar and computational system and automatic flight control, there's the robotics part of it, was so good it would wait until the last possible nanosecond to make flight changes to take it up and over the ridge. The Air Force was losing pilots because they would lose faith in the ability. They would see this impending obstacle coming and they would lose faith in what they were seeing and take over manual control. And much like the analogy we heard about turning over control in an autonomous vehicle, a car, the same thing was happening here. They couldn't react fast enough and you'd end up with mishaps. So they literally, it's a two-seater, the F-111, they would literally take pilots out with somebody who is experienced in the controls and the other person just watching to gain the trust of the system to where that they just knew that the plane would take care of itself. Now, I submit to you that that's rather dramatic, but hopefully it's something that we can remember. And we're going to see that to some extent with AI and robotics in modern society. We're getting some of that with our just everyday smartphones that we have. And as we start to use autonomous vehicles, we'll do that. And we're getting it every day right now with various types of assistants, back to these cobots that I talked about, back to working alongside of AI and robotics every day. We'll soon learn where the bounds of trust are and where the edges to that are, and we can contain our excitement on the inside and be very cognizant of what the issues might be on the outside. So where are these assistants? I talked about having them in a technical inbound call center, but we're also seeing them in manufacturing, where the robots do a repetitive job and the humans work right along with them, doing the small adjustments, the things that humans do best. We're seeing them in warehouses where we have automated forklifts. We have things that will handle the big, heavy, dangerous parts of warehousing, and then the humans handle the better aspect of that. And then I think inspection assistance is another really great place where you can have a combination of human, robot, and AI examining parts. The AI is constantly learning. The robotic part of it will test each and every item, whatever it happens to be, exactly the same. And the human will notice the nuances that neither of the other two are doing and provide information back into the system to make it better for the future. So I think excitement and trust takes over fear, but keep in mind it takes at least 10 good things to balance out one bad thing that typically that happens to us. So we're going to see alarmist newspaper stories. We're going to see a number of things out there. All I'm telling you is focus on trust and don't lose the excitement.
Thank you. Thank you. Thank you, Professor Donald. Can you unmute, please?
There was an article in this week's Economist that was pretty interesting, where they said, is automation replacing jobs? Don't be so quick about it. And they actually showed that during the, they divided jobs into repetitive jobs that robots could do, and then more creative jobs that still require humans. And they showed that the percentage of repetitive jobs had gone up during COVID, not down. And so the idea that people are, that they're losing jobs right now to automation may not actually be correct. I mean, it's something that we all say, but there's actually the evidence shows the opposite. And when you think about it, Amazon hired hundreds of thousands of people. Amazon guaranteed 2-day delivery, and during COVID, it went down to 2 weeks because they just simply didn't have enough people to deal with the increased volume that they were having. And if you look at artificial intelligence is not intelligent at all. It's just fancier statistical models, predictive statistics. And there's been a trend that goes all the way back to Ford that trying to break down the work into smaller and smaller pieces that can be measured. So there was this guy named Taylor who would run around the factory floor and say, well, gosh, if we put this on the right-hand side instead of the left-hand side, it would save a fraction of a second every time we did it, and we could speed things up. So in a sense, what they're doing, and this is on steroids in Amazon warehouses. They actually have lasers that can help determine whether people are slacking off at all. And if you get caught slacking off 3 times, even if you've worked there for 5 years, they'll fire you. And Amazon is actually based on a premise that no one's going to work there in their warehouses for very long because they're so awful. And it's just a horrible job. And when we talk about training these deep learning systems, basically structured, the way that worked is that what would happen is they'd hire people to look at a picture, and they'd say, well, in this picture there's a car and a moose and a squirrel, and they'd identify where in the picture those things were, and that's what and then they do it for the next one, and they do it for the next one. And you can always gamify something like that in your mind where you're saying, okay, I can do this faster than anybody else, and I can do this. You can do that with any sort of work, but it's actually very, very, very low paid, and as you can imagine, it's quite tedious. Amazon invented a system called Mechanical Turk, which anyone can use to hire people to do repetitive tasks. And the vast majority of the people that do it are in very low income countries like India. And so where, you know, making an extra dollar or two a day makes a huge difference for you in your life. It's not something that all that many people do in America. And there's levels of jobs. I've used it to do psychological surveys, and those are interesting. And I also, because I want to publish them in peer-reviewed journals, I calculate how long it takes, and I figure out how to make sure they're getting paid $10 an hour for doing it, because I'm not into exploiting people. And so one of the things that kind of leads to is that there's actually no intelligence in artificial intelligence. It's just being used in factory automation is a more sophisticated way of what Taylor did. That's the way, in fact, Amazon developed a software that would help them hire the right people by looking at all of the resumes and then mapping the people's productivity to the resumes that they got. So they could just look, their dream was they could just look at a resume and they would have a much higher probability of hiring the right kind of person. They had to abandon it because all of the engineers that wrote it and trained it were white males. And because of that, they were only hiring white males because that became the baseline for who was good and who was productive. And that's kind of an indication. I mean, when we get to autonomous vehicles, you know, there's an old joke in the computer industry which says they're 2 years in the future, always have been, and always will be. Which is it's interesting how slowly we do something which is, you know, it is a repetitive task in a lot of ways. I mean, there are traffic laws, there's a lot of rules that you can build into a system like that don't require any actual judgment. There's judgment that has to happen, and that's the part that's been a real stickler. And it's interesting, you know, there's the ideal future, which what Karl Marx dreamed of, which is that automation would allow a post-scarcity society and people wouldn't have to work anymore. That was Marx's dream. And he wasn't against automation at all. That's completely incorrect. And but deep within it, I had dinner with a guy named Doug Engelbart once, and Doug Engelbart is well known because he invented the graphical user interface. And if you ever want to have fun, there's a video you can watch on YouTube called The Mother of All Demos, which is a video of him doing the first demo of the mouse and top mouse. And Doug said he had the original mouse in his garage, which was a toilet paper tube that was cut in half and wrapped with wire. And that was and he used a radar display for the display because there weren't really very sophisticated graphical systems at that time. And Doug told me, I am so bummed out about what happened with the graphical user interface because I never dreamed of a graphical user interface. He said, that wasn't what I was aiming for. What I was aiming for is an assistant that would increase people's ability to do the kinds of things they need to do. Something where they had to do complex linear equations or differential equations or integral calculus or things like that. That it would take somebody who was pushing the edge of what they could do and allow them to make that edge go farther. That was what he was dreaming. He said there would be lots of graphical user interfaces for different jobs and different purposes. So the idea of dumbing it down so that no one even knows how computers work anymore. The knowledge of how computers work is declining, not increasing. and has been. And so when the key is that when we look at intelligence and what we do, our minds don't end at our skulls. Now we become more centered on what's called embodied cognition. And what they realize is that we are not just our brains and our bodies, but we are how our bodies interact with the environment. And so when you look at memory, the room around you is your memory, because you know where to look to be able to find certain things. I mean, you don't have to store that in your neural system. It's there, it's part of your memory. And so our sophisticated devices become part of our memory too, and part of our cognition, just like Doug was trying to do, is to make it so that we can increase our minds and our cognition. And right now, robots and artificial intelligence are kind of doing the opposite. And I think that that's something that if you were trying to learn about this, we know so incredibly little about how humans work that we're just, talking this science fiction stuff about how, I love science fiction. I've read tons of it, but we are so far from even understanding how language works. I mean, you think that, and I'll finish up, because you think that Alexa has gotten smart and that it understands your language and things like that, but it's just a dictionary. It recognizes sounds because we've got so much data of people talking that we saved. We can train it, and it's become sophisticated training. But then it uses these things called ontologies, which are just basically dictionaries where words are linked together. It's like a thesaurus and dictionary merged together, and that's it. It's just looking up words in a database. It doesn't have anything to do with human language. Human language is something that we use to work together to do the incredible things that humans do. That buried in human language is the experience of all the humans before us. It's there. It's memory. It's this incredible memory that's distributed across society. And how we get from here to there, to wherever it is that we're headed. Maybe Karl Marx's dream of a society without scarcity, and where people don't have to work. That would be great. And actually, I'm not quite finished. Is that work is it's incredibly important to us, and having work that we feel is making a difference and can contribute to the world and society is absolutely critical for good for humans to be human and to feel good about themselves. So right now, I know I'm going on a little long, but right now we're measuring the success of these things in dollars or yen or whatever. And
thank you.
Okay. I'll finish now.
Yes, actually, like we have our. No, definitely. I will get back to you because we have our other speakers. Yes, Mr. Saurabh, even Mr. Jason, Mr. Brian has very good startup on Ahura AI. So even previously he joined in World Talent Economy Forum. He's working with Sir Richard Branson, and he has some excitement. And our actually Asia Pacific people love to know more about his startup. So that's why, because our audience has some questions and other things. So Mr. Brand, Mr. Saurabh, I'm coming to you. Just I want to give a chance because he has also an important meeting. So Mr. Brand. Yes, can you unmute, please? Mr. Brand, can you unmute, please?
Hey, can you hear me now? Thank you so much for having me again, Sharif.
Yeah,
it's always good to be here. And Donald, it's great to see you again, as always. I'm one of those companies that Donald was talking about that's perennially 2 years in the future, trying to build the future. But we do run an artificial intelligence company. We invented technology that enables people to learn 3 to 5 times faster than traditional education. So what we were able to do is, after collecting a significant amount of data on our users, we're able to identify the optimal way to deliver content to an individual in real time based on their unique needs in that moment. So not only do we transition between text-based, experiential, and video-based learning, we're also able to use deepfakes to deliver the video content in a way that engages with the individual on a much deeper level. So, for example, for your audience, anybody that plays poker, you're probably familiar with being able to determine people's tells, to identify whether someone is bluffing and has a terrible hand, or if they have a fantastic hand and you should get out. Well, it turns out if you collect the right information from computers, you can actually identify whether someone is inspired or tired. You can figure out if they're energetic or motivated or frustrated, and everything in between. So if you're watching a video of someone explaining something at 7 in the morning, maybe you had a really good night's sleep, you ate a nutritious breakfast, you woke up and worked out, you had your morning coffee, maybe you need to have the material explained to you by a 65-year-old British guy with a posh accent and a tweed jacket. But maybe at 7 p.m., if you had a really tough day at work, maybe you ate really poorly, you stopped by McDonald's on the way home, maybe you had a fight with your significant other, maybe you need a 25-year-old fashion model explaining the material to you. And so maybe if you're learning Python and you used to be a truck driver or a worker at Amazon's warehouse or something like that, maybe you need to have Taylor Swift or Beyonce explaining to you how to program in Python or React Native or Java. And so we're able to actually make that happen, to enable people to learn significantly faster, retain that information longer, and of course be able to focus much more effectively. Now, one thing we do, to Donald's point, is for every license that we sell to corporates, we give away a free license to members of underserved communities globally, especially with a gender and diversity lens. So people like myself that grew up in a refugee camp, or people in sub-Saharan Africa or slums in India. Now, what we do is we have an ethics review board. We've made legally binding commitments around what we will and won't do with the data that we collect from people, because we are very much the opposite of the exploitative data model that Zuck has. But what we do is we give each user not only agency over their data, but we give them the option to opt into selling their data if they want to. Now, it's an opt-in. The standard, the default is that none of their data is sold to anyone. But if they if they choose to sell their data, they get to choose which categories of data they want to sell and to what categories of buyers. And because we don't just sell it for advertising, we sell it to a slew of different types of buyers, we're able to generate $200 of revenue per month per user from their data. Then we turn around and give 70% of that back to the user. So now that's $140, which probably isn't a lot to people like us, right? And the other people on the panel or a lot of the viewers, that's a bottle of scotch. But $140 for someone living in Ghana on $5 a month is 2 years' salary. $140 to a person in a refugee camp that lives on $1 a month is massively transformational. And so we give people the opportunity to do that. To Donald's point about a post-scarcity society, we don't necessarily believe in universal basic income. We believe in universal earned income. So the ability to earn that continual income based on selling your data or other things that you have. So I'm going to pause here. And I know I have to pop out. I have a meeting with the Richard's team here in a couple minutes. But thank you so much, Sharif, for having me.
Thank you. Thank you. Thank you, Mr. Brand, for joining with us. Thank you. Mr. Shorop, sorry. So what do you want to add for today?
So first of all, thanks all of you, and it's really great panel. I really love this panel. I mean, I never expected. I really love this, and it's really interesting discussion. So thanks, Sharif and everyone. So I was like patiently listening because I think they're really good points. So I'm actually doing research on soft and flexible robotics from India, and along with that, I have my own startup, which is also kind of inclined to the robotic, or maybe I mix this thing that is robotics and renewable energy. So this is really interesting area I feel we can work on in the future if you think about the sustainability factor and also the aerospace. So when we talk about soft robotics, or maybe flexible robotics, or maybe in a way compliant robotics, I talk all these three terms. So AI, or maybe AI, machine learning, all this kind of all this kind of training modules maybe will be very helpful to them. And this, I think we need some robots in future, where let's say human civilization can take it to the maybe Mars or Moon or something. Because if you imagine the human is surviving for Mars or Moon or some colony, I mean beyond space, beyond the Earth, so we need some assistive robots, and they need to be intelligent also. So we have to understand the human nature and how to assist them. That is one aspect. And also we have to also take care of the safety of the human civilization. Maybe if we think about the space tourism, or maybe the space missions and all these things. So I feel that AI is taking a very important role, obviously. And along with that, I think nowadays we are also talking about beyond AI, that is like reinforcement learning, machine learning stuffs and all. So I think it's really interesting the era that we are in, and how we can integrate. Because nowadays we're talking about robot which is smart. That means the robot which we already have is not enough smart, and this AI and maybe machine learning is actually making them very smart and understanding things, which is like really interesting for the future, to help us, to assist us. And also like in a way it could be also competitive. We see a lot of movies, a lot of information, and all this discussion we are going on. So I think this is one interesting stuff. And as I told that I'm dealing with the biosphere stuff, or maybe dealing with some sort of robots which is made of soft material, which is made of flexible materials, or which is not like a conventional robots that we see. This kind of robots also needs like the way creature walks or moves, or maybe if we make some sort of bioinspired kind of robot which is able to explore the water body, and also it can explore some sort of uneven surface, that needs that kind of walking module or movements. And it's like collective intelligence, right? So we have to recognize that problem, which is like maybe we can't decide previously. Like if you think about space and space robotics, it's completely uncertain. Maybe we know very little bit of it, we can assume very little bit of it, and we can actually predict that this can happen, and then according to that we make the modules. But if you think about the space modules, or maybe the challenges that we can face in the future if we go for space exploration or the space mining, robots are very important. Even we have seen that during pandemic we need robots, assistive robots, which can actually give medicines, or maybe some sort of care to the patients who are in maybe ICU and all. So I think we need robots, obviously, and we have to see that how to deal with it. Because human civilization had humans maybe in terms of the employment. We see that nowadays, like initially the first industrial revolution, second, third, we are in maybe during the 3.5, and we're going towards the 4.0. So when we're going for this kind of revolution, we have to understand that how human and machine can work together. That's what the human robotic collaboration comes into the picture. And this is the way we can actually see how cost effective things we can build, how maybe in the case of the lot of materials, there are a lot of cases we can see that if human comes into the picture, maybe near to the some sort of area, there has been radiation or some sort of stuff which is very dangerous to human, and it can impact very permanent. So we need robots to explore those areas, to make safe haven for human civilization, or maybe that kind of explorations. And we go ahead. And for example, the moment I talk about like space exploration, we're talking about Mars colony, or maybe lunar colony, and we need 3D printers which can actually use maybe the Martian material itself. Like there in Mars we have thorium, or maybe some more rock in powder form, or maybe in some sort of very tiny kind of modules, or maybe that thing we can actually use for the Martian home initially, to stop radiation or some sort of shield. Because until human reach in that kind of areas, or maybe in terms of planetary exploration, we need things already built. we need energy supplement already, then only we can go and we can explore. So I think robotics, and then when AI comes into the picture, it's a really good combination, and we have to understand how we can actually play with it for the betterment of human in the world or outside the world, or maybe as an international collaboration or something like that. Or also we can talk about let's say the space debris, right? We have to understand that how space debris are formed, and then it's like in different layers, and we have to actually collect only the space debris. We can't touch the ongoing satellites which is like active. So we have to recognize those things, and it's like the mistake could be $1 million loss. So we have to understand that how we can implement. So I really love this topic, and I think that all the great people, we can actually sit together and make some very good strategy for the human development, not only for human, maybe supporting a lot of organisms, and maybe the creatures that we have around us. We can save them, and we can make heaven for them in Earth, or maybe beyond Earth. So thank you, King, and looking forward to other panelists.
Thank you, Mr. Shorov. Mr. Jason.
Hey, what's up? First of all, that Brian guy's stuff, that sounded pretty awesome. I mean, if that really works, and if that's a good business model, that's really pretty cool. That does way allow people to
Mr.
profit off
Jason,
their own.
like, we cannot hear you clearly.
You can't hear me? Can you hear me now?
Yes.
All right. So, thinking about the future and about AI and robotics, it's going to be it's pretty interesting, and it's going to be a little more complicated than. It's not just going to be just AI, but there's also going to be variations of collective intelligence, in the mix. And I'll make this quick, but I'm curious because we got a lot of good thinkers here. I'm wondering, like, let's say in the future we have this hypothetical situation where there's one job open, and we have one robot that wants to fill the job, and it is controlled by a distributed AI that also has 99 other bodies. And then another robot that wants the job is controlled by a human, but remotely. It's a real human, but he like through VR or something. And then there's another robot that wants the job, and it's controlled by a digital proxy of a human. So it's like a narrow AI, but is functioning in place of a human. And then there's another robot that wants the job, and it's controlled by a digital being, but it's based on an mind upload from a real human. Who would ethically should get the job? Who do we value more than than others in that situation? Just curious. I'll throw it back to you guys on that. Go ahead, Sharif.
Thank you. It's really great discussion. There are a few questions from audience. I just take one or two questions. Will it be possible to build artificial emotional intelligence? This is one question regarding that. Will artificial intelligence in the future reach the state of self-perfecting intelligence? So these are the things I think our audience love to know more. Dr. Eric, what do you want to add?
Well, I'm not going to answer those,
Okay.
Artificial, but I would like to. I'd like to talk about something that is real, that's happening now. We're talking about the robotics, and some of you have mentioned, like autonomous vehicles. Well, I sit in an autonomous vehicle, 5 nights a week, and I know exactly what's happening in an autonomous vehicle, and the fears that people are having about the autonomous vehicle are unfounded. They have been resolved. It is done. Okay, the technology is there. Okay, the only thing that needs to be done is adoption. Okay, it's nothing to do with the technology anymore. That, I mean, of course there's going to be some blue moon, 1 in a million chance of something happening, and blah blah blah. Same thing happens with human drivers and human cars. This is no big deal. Okay, a rock falls off of the hillside, comes down. Chances are, actually, if something like that were to happen, the autonomous vehicle are probably quicker to figure out how to get around that than a human driver. But the reality is, unforeseen circumstances will occur, and the autonomous vehicle will not be able to deal with it because of the time, the short amount of time elapsed from when it occurs and what the reaction time can be. That's going to happen. And as far as people are talking about, who is liable and all that, these cars are jacked with cameras and other data collecting sensors. Okay, they will know practically what you had that evening, how many drinks you had before you got into that car that drove in and hit the autonomous vehicle. They know everything about you. You're not going to be able to have a word in sideways, edgewise, to be able to claim that, oh, it's the autonomous vehicle that did something wrong. It ain't going to happen, okay? These vehicles are bulletproof liability-wise, I'm going to tell you. And if it isn't yet, they're going to make it so that if there's ever an accident, it ain't the autonomous vehicle's fault, guaranteed, okay? It's going to make it so bulletproof that you're going to be doomed if you're a human driver. Okay, and that's going to accelerate. That's going to accelerate adoption of the autonomous vehicle, because when fewer and fewer drivers when there are going to be fewer and fewer human drivers, then the premiums for them go up, because the insurance company have to cover their bets, basically. And when you're going to have fewer drivers, then everybody has to pay more for the insurance. And if they're going to pay more, then people are going to say, oh, forget about it. I'm not paying $5,000 a year in insurance. Okay. And every time that there's an accident, it's my fault. Well, forget about it. Okay. So that's what's going to happen. And when another drops out from paying the premium, then the remaining pool of payers have to pay even more. And then ultimately it's going to self-destruct, and people are going to say, I don't really need that. I'm going to use the autonomous vehicle instead. And that's what's going to happen, is the economics is going to cause that. As far as the job concerned that people also address, trucking unions and other unions or other groups who feel that they may be impacted negatively, they have to think about it in a different way. When you think of yourself as a truck driver, you should not think of yourself as, oh, I am the person that sits behind a wheel of a truck and I, steer and step on the gas and the pedal. No, your job is to deliver goods from one place to another. That is your job, to deliver goods from one place to another. And you do that by whatever means possible. Okay. You do that before the existence of trucks. You drag that thing from one place to the other. Then we invented wheels. Then you put these things onto a carriage or something with the wheels, and then you drag that along with the wheels. And then you domesticated horses, and you rigged something up on the horses, and you get the horse to drag that along. Okay, and then you discovered sails and winds, and you put it onto a boat and you send it along the river. Okay, and then you build a darn canal like the Erie Canal, and then you do that where you didn't have a river, you made the river. Okay, and then you had cars, and then you had trucks and all that. Those are just means to do the goal of bringing goods from one place to another. Okay, if an autonomous vehicle can do it, then hallelujah, we do it. Okay, and if you think about how we have done this over in the human history, okay, from dragging things to having wheels to having sails and canals and all that, every time when we did this, okay, we did not kill jobs, we created thousands of more jobs. Okay, every time you created a canal, all right, then every 12 hours worth of sailing on that canal, you had new business. You have people, you know, restaurants, and you have entertainment, and you have stores and all that. And every time you created a wheel, then you had wheelsmiths and people who created axles and people who had to source the goods to the wood to make those things. And then people realize, oh, maybe you can put steel. Then somebody had to smelt the steel, and then have all these new jobs that come created because we were not satisfied with dragging goods from one place to another. So the workers, the truckers, should not be fearful. They should say, thank you, so I don't have to sit behind a wheel and destroy my back so that by the time I'm 50, I can't even walk. Okay, that's what happens to drivers, truck drivers. By the time you're 50, by the time you're 60, your back is destroyed. Okay, so hallelujah, you don't have to do that anymore, and let the autonomous vehicle do that, and you will have dozens of new jobs to pick from, choose from, that you can do that will be much better for your body, much more higher paying for sure. Because every time when we went from dragging things to, you know, using wheels to using sails and all that, the economy became more wealthy, and people got more, the regular everyday workers become wealthier. They got more money, they could be able to buy things, and that grew the economy. That grew the economy from basically $0 to now what we have globally, you know, a quadrillions of dollars in value. Okay, that happens. And so people should not fear autonomous, or, you know, robotics, AI, whatever. Use it for the goal that they're supposed to be used for, and guarantee that thousands of jobs will be created, because that's what history has shown. Okay, it has shown that time and time again over the course of 10,000 years. So it's not going to change.
Thank you, Dr. Eric. Professor David Smith, yes.
Robotics and AI are going to impact how we see work done, how we prepare our educational career, and others like that. The fact that we're combining actuators, sensors, to do tasks that we have done for millennia will change the integration requirements. Your question from the viewers are great questions, and are ones that, as I begin to look at where this future goes, I do have to go and put on my hat as a professional futurist and begin to understand the nuances of the ask. Some of the real nuances are, yes, automation, autonomy, robots, the broad field of AI will change the mix of employment. Will eliminate jobs. It will eliminate types of jobs. But as we do the other things, it will create new types of jobs. And that's one of the real important things I think is often missed in the discussion around this. You know, going back to the early days of agriculture, yes, the metal plow replaced people working the field. When I went to a tractor, yes, it replaced more people working in the field. But you begin to see them beginning to do other things, and you saw productivity rise. And that's how we were able to begin to feed the global rise in population, is actually doing the types of things that we're doing today. I mentioned in the opening remarks that agriculture is one of them that's going to be immensely impacted by robotics and AI. And it's going to be the same type of evolution we saw from thousands of years ago, continuing the future. You know, I mentioned this yesterday. I want to mention again in this regard. Usually, technology is not the problem. Usually, people are the problem and they're hardest to deal with. When you look at robotics and its impact in society, and AI enhancing it even more, it's going to be much like was just said, how we each one begin to adapt to it and learn to it and realize that we truly are today in a time of lifelong learning. That's not necessarily going back to a university, but it's looking at how to apply the things. I just did a quick look a while ago at boot camps for robotics and AI. There's hundreds of boot camps teaching you these skills in short 3-week, 6-week type of sessions. So if anyone in the region wants to learn these skills and advance yourself, there's a lot of opportunity there to do it. Most of these are offered by teleeducation. And so you can begin to do things like that. You know, to me, the future is the people who look out the windshield and not in your rearview mirror. And particularly when it comes to this topic of robotics enhanced by artificial intelligence, that is truly where we are right now in this evolution. Robots used are, wow, 50 years old now, as you begin to see how robots are used. The application of AI will take them to the next plateau. Thank you for having me be part of this.
Thank you, Professor Rob.
So the issue with regard to, Eric was talking about the unions and the truck drivers, and the issue with the unions and the truck drivers, I think, comes down to the one of the big problems we have to deal with regard to automation, and that is what we're talking about is turning truck drivers into accountants and pursers. It's a better job for them, but it's a different union. So the union is their objection to the autonomous trucks really has to do with they don't want to lose power because the union can't transition because there's another union that already is where they would have to go, and so their bias is driving an opinion that is counter to the best interest of the drivers and the best interest of the industry. When you're short 300,000 drivers, the industry is going to have to fix it regardless. So unless you can fix the driver problem, you're not going to stop the trend. But if you want to fix the union being adverse to the trend, then you've got to find a way that the union can benefit, because people are not going to act against their own self-interest. And so and this becomes an issue with regard to any transition. When you're moving a technology into a market that's going to change how people work, the people that are invested in the status quo are generally going to fight it. Back when I was working at IBM, I did a study that got me into the executive ranks of IBM because of the way I approached it. And what we discovered was one of the reasons why one of our products wasn't selling is because we were automating and eliminating jobs. And one of the decision makers involved in the selection of the technology almost always was the person in charge of those jobs. And span of control equates to status. And so the product was reducing the individual status, thus he or she was acting against the technology. And the workaround was to disable the automation capabilities so the workers' jobs weren't affected, so you could get a positive vote on the sale. But that removed a lot of the economic advantage of the technology, which eventually was one of the causes of the division failing. So the end result is when you're ever moving technology into a market, you really have to look at the underlying dynamics, and you have to address whatever the critical path is. Another example is in a different area. I did a postmortem on a sale to Rockwell International, and the company selling to the technology determined that their technology was acceptable. There were 5 divisions, was acceptable to 3 of the divisions, but 2 of the divisions it was absolutely unacceptable to. So they spent $1 million doing prep and demonstrations to the 3 divisions that was already going to accept the technology, and ignored the 2 divisions that didn't like the technology. And after spending $1 million on the sales effort, they failed because the two divisions that didn't want it didn't move, and they voted against it, and it was a complete waste of money. By the way, writing that up was a great way to earn the permanent animosity of the sales team leader that executed that failed $1 million effort. But the failure was, if you identify problems rolling out technology, you can't use multiple choice and just pick the things that are easy. You have to address the folks you have to overcome that are hard against what it is you want to do. You have to remove them from the jobs. You have to find a way to get them to move. You can't just ignore that. And as we move automation and robotics into a lot of these markets, being aware of the human dynamics are important. I did a tour at Mercedes-Benz a few years back, and they were showcasing their wonderful automation with regard to building Mercedes-Benz cars. And one of their showcase areas was a worker doing picks. In other words, picking parts out of a particular bin, putting them in another bin that equated to the car so that they could be assembled. And what happened is the computer shined a light on the bin that they were supposed to pull the parts from, and then shined another light on the bin they were supposed to put the parts in, but provided no guidance on to how to fit the part into the place it was supposed to go. And apparently the part had to be inserted in a particular way for it to go. So I would watch this guy, light goes on to the one bin, he picks it up, light would go on the other bin, and he's going, well, does it go in this way? Does it go in that way? And that was their big showcase of automation, because they'd left the guy in a job that clearly shouldn't be human done anymore. A computer would have been far more, and a robotic arm would have done this job far more effectively. But the labor union required Mercedes-Benz to keep these people in place. Thus, they put a human, they integrated a human with technology in a way that didn't benefit the human at all. I mean, just watching that guy, it was just a horrible job. Some other stuff that I observed was whenever they called a meeting, everybody would leave a particular area in the line, but the line kept moving. And so you'd see these cars come through and nobody was assembling anything. And so when we began the tour, there was this area where unassembled cars or failured cars would be. And there was one car when we started, there were something like 30 cars in that area when we were done, because they kept outputting incompletely assembled automobiles, because for whatever reason, they weren't stopping the line. Once again, these were all tasks that should have been done by machine, but because of some weird policy that required the lines to continue while people were on break, it was resulting in some significant problems with regard to completed assembly. Just horrible stuff, but showcasing the labor dynamic in terms of implementing robots, where they were required to use labor in areas where robots were being better. And by trying to intermingle robots and people and doing it badly, they didn't increase efficiency, at least not while I was observing it. They actually seemed to decrease efficiency and make the problem worse. And I've got to tell you, after watching that factory work, I was convinced I was never going to buy a Mercedes. That it was just like, what the hell? So the end here is, whenever you're looking at trying to implement an automated process, you kind of have to look at it holistically. You have to look at the collateral damage you're going to do to the other parts of the company, take that into account, and mitigate it so the solution actually works. Just throwing robotics. I mean, Tesla was a good example of what happens when you try to automate something and you don't understand what it is you're automating. They had a huge problem trying to ramp up production, and they still have major problems with regard to quality control. Robots should be better at quality than people are. That Tesla's showcased an implementation where they're worse, and that just means the implementation is bad. The people doing it fundamentally didn't understand what it was they were doing, and they just started throwing tools at things. You have to look at things holistically. You have to look at the entire system. Another example was back again at IBM, we had an automated line that was building storage machines, and we had 100% failure rate at the end of the line. That 100% failure. Every machine that was coming off this line was failing, and people couldn't figure out what it was. Worse, it was supposedly cheaper to dispose of the hardware than it was trying to fix it. And so we were just dumping hardware into landfills. It was the damnedest thing I'd ever seen. The mistake was on the QC level. Every QC check was only checking the process that occurred immediately before it. So what wasn't being caught was when a process broke something on a prior process, it wasn't being caught. And what was happening is, during part of the assembly, one of the processes was breaking something else that had already been done. And the only full test was done at the end when the hardware failed. The fix is you needed more intermediate tests to find failures on the line. You couldn't just test the preceding process. You had to test the entire system regularly so it would come out accurately. That was an early application of automation that really went bad because people didn't think through the process. This takes us back to simulation and why simulation is so important. Because you can do this stuff in simulation, you can have 1,000 failures. It doesn't cost you anything because you're not doing it live on the line. You're doing it in simulation. And that's why simulation is so incredibly important as we move to automation and start testing this new hardware. Otherwise, we're more likely to break things than we are to fix them. We have timing issues when we're intermingling people and machines. We've got quality issues, as I mentioned, when you're intermingling people and machines. And you've got huge safety issues when you're intermingling the people and machines. We called one of the storage things we were building back then a human Cuisinart, because if it fired up while somebody was in doing the assembly, it would cut them up into little itty bitty pieces. It was just a horrible situation. And so when you're building this, maybe we don't have a person engaged with the machine while it's powered up because the danger is just simply too high to put a person in that environment. And honestly, that's where a lot of robots are effectively used today. They're used very effectively in areas where it's just simply too hazardous for people to see. We should have moved to automation and robotics in areas like mining, for instance, long ago, because while people are cheap, the environment is incredibly hazardous to human life. And so stepping back and saying, human robots and AI aren't a panacea. You've got to look at the problem, make sure the problem will accept the automated solution, and then take into account what the collateral damage, the unexpected outcomes are of the implementation, and then mitigate it before going live. And that's why it's so important to do simulation. Simulation. Make sure it works in simulation, and then you can take the training material and apply it to the real world, the learning and apply it to the real world. No lives lost, no systems destroyed. You've done your testing up front. So that the idea of doing this stuff successfully, heavy test, then implement, not implement live. Don't throw technology at problems. Think it through and do it holistically.
Thank you, Mr. Jamsid.
Sharif, thank you for assembling this wonderful panel to talk about this very important issue. I'm always learning something. I'm taking notes. I just wish I could read them. And bravo to some of the previous speakers, all of them actually. And Rob, man, that was great. I just am hesitant to follow that on your heels there. But, one of the things I would like to say is that policing will always be behind the cheaters. Someone's probably data mining Bitcoins on my computer right now. And policy will always lag behind innovation. So these are just the facts, but don't be afraid of the facts. And the fact is the world is changing. Now there's millions of people in the United States that want a pre-1960s United States, and they are only imagining a world that never really existed. It was only on the TV shows like Leave It to Beaver, Mayberry RFD, something like that. But the 60s was a time of social upheaval, change. It was time before civil rights, and it was a time where people just, hey, government's lying to us about the Vietnam War. Wow. I can remember carrying a sign that said "Make love, not war" before I had done either one. And so, it's time for the young people to take charge here, show some initiative, get trained, because these technologies are going to be yours. They're leaving me behind already. So, don't wait for me to fix it. You got to fix it, young people. And that's a challenge. Educate yourself. Don't wait to be taught. Teach yourself. Find out. There's plenty of stuff on the internet that'll teach you what you need to know for tomorrow's world. And, don't worry about yesterday's world. Yesterday's in the rearview mirror, as David Smith said. Look forward and don't be afraid. Your decision-making is always impaired by fear. So face it with confidence, because you can do differently than we have done in the past. And, we're talking about new jobs. Yeah, new jobs, but they require new training. And what about new training methodologies? because our educational system is based on an agrarian society. I didn't like school and school didn't like me. And it's okay. It was old then. It's way behind the times now. We have to reform our educational system. Good luck trying to do that. What about all the teachers you'd be putting out of job? There's everything you want to do in the future is going to face resistance. And some of this resistance is going to be natural human nature kind, and some of it are going to be far powerful, invested interests that want it the way it is, want to keep it the way it is, even in the face of radical change. We're facing radical change. We have to change radically in our thinking. And I'm not trying to change your minds. I'm trying to change your hearts. Tell you you can do it. Have confidence, courage. Face it, and face it without fear. These are the things I want you to remind our viewers that this is your world, and it's up to you to change it. And the educational systems are just part of it. We talked about the autonomous driving and the insurance companies. Do the insurance companies really want you to not have any liability? Oh man, then they go on. We don't need them. It's like that. We were talking about Bitcoins and cryptocurrencies, and do the banks want that? No, we find out we don't need them. So they're powerful, entrenched forces that don't want these things to change. And so, will it be easy? No, no one said it would be easy. No one promised you an easy life, but you have to acquire the skill sets that you need, because they aren't the skill sets that I needed. Don't train yourself in COBOL programming, man. That's yesterday's technology. Change yourself. Sorry to make Dr. Eric laugh, but it's important to know what you need to be successful in your future, so that you can have value in the marketplace. Everyone needs to earn a living. So that's important, absolutely. But I also say what you have to do is think about your impact on the planet. Think about changing yourself first. Change those in your sphere of influence. Change your community. Change the way they think. Change the way they behave. Because it's not really so much thinking as the behaving. How are we going to behave differently? And that means collaboration, cooperation. These are not things that we're necessarily good at. But we have to do this. And we have to, the boundaries that exist in nature are mountain ranges and oceans and rivers we can't easily pass. So, there's no such things as lines on the map in nature. So we can't think of us as this country, and the people who say America first are saying America alone. And you can't do it alone. We're in this together. So we have to start thinking like this as a global citizen, and these solutions have to be global in nature. And if you have a technology that other people don't, share it. Why wouldn't you? So this is one man's opinion. Thank you, Sharif, for allowing me to give it. And if there's any concluding remarks, I'm sorry I won't be able to stick around, but Donald can do my share. He's heard it before.
Okay, thank you. Mr. David Schumacher.
Yes, thank you, Sharif, and thank you to each one of the speakers. There's been a broad range of topics. There's been talk about things that are working and the things that don't work, either technically or, as has been pointed out more importantly, among the humans, among those that are in business and in government and so forth. But we've had a lot of discussion that's been really good this morning. I want to go back and talk about excitement, because as we're looking at the youth of Asia Pacific, I think being excited about what the possibilities can be is the driver going forward for their future, as far as, well, in every area, because this technology, AI, robotics, and any of the other technologies are going forward whether we like it or not. Now, what form are they going to take, and how much do we trust them? So work on your own trust level. work with the technologies that are available today as you have them available, whether that be a smartphone or a smartwatch, or whether it be computer programs on your desktop or laptop, or whatever they may be. Work on that and educate yourself so that you can take advantage of what is coming and participate. Because in participation, you do a number of things. You maintain your excitement, you build what you can trust and what you can't trust, and then you see paths for where you need to educate yourself. And I agree, education is just not a degree hanging on the wall. I look at certifications, I look at industrial training, commercial certifications, look at all the different places. We've talked about them in past episodes, but participation is where it all comes down. It's just theory until you participate. So to the students that are watching this out there, look for a place to get involved. You need to learn, you need to apply, and perhaps we can have another discussion, we've had them in the past, on what these avenues are for how they can participate and how they can educate themselves. But I think that's my mission, that's my message to the youth of Asia Pacific. And I too must go, I'm running up against another time constraint. So these are my closing remarks as well.
Thank you. Thank you. Professor Donald. Thank you. Unmute, please.
I really appreciate what Rob and everybody have been saying. It's very interesting. I think if you consider Brian, right, what he's talking about with training, being able to basically identify places where people are deviating from some sort of norm, and be able to use the methods to be able to get them to that norm, so that the information that you're trying to get in them is absorbed more readily. So you have to ask the question, well, how do you know that? And so what you wind up with is a system where the people are basically becoming almost like deep learning machines, where you're giving them, training them to do certain kinds of tasks. And I think we need to be cautious about things like this. But instead of going on too long, I want to make one really important point, which is that whole thing of how we measure it is extremely important. And it's been very recent in the history of humanity that we measure things in terms of dollars. And in fact, I have a very sophisticated Mexican friend. He's having his kids go to school in Germany and Mexico because he doesn't like the U.S. education system. He doesn't like the U.S. culture, and he's looking forward to going back to Mexico. And there was an article today, and I read both the Washington Post and New York Times, so they blur together about how Americans are flocking to Mexico right now. And the whole idea everybody's coming here because it's such a great place is actually it's not true. And plus, we don't let them in thanks to weird immigration laws. But consider you and what is valuable to you in your life. Do you like to go to music shows? Do you? Well, how do musicians get to be musicians? You have to work your ass off. Like, if you look at the greatest musicians, they went through a period in their life where they were practicing 7 or 8 hours a day, 7 days a week. I mean, it's not something that you can do, and it's also not sustainable economically. We have a joke, musicians have a joke, which is they say, did you hear about the musician that won the lottery? Well, he plans to keep gigging till the money runs out. And The point simply being that we as a society aren't, we don't value, especially in America, we don't value things that that sustain us, really. And I really agree with the idea that we need to start educating people in a variety of ways, because in this show we focus on saying, get an advanced degree, learn these technical subjects, learn calculus, blah, blah, blah. And in the United States, about a third of the people in the United States have bachelor's degrees, and the other 2/3 don't. And we're developing a system where we're kind of putting down those people and saying, well, you wouldn't be poor if you just worked harder and went to college, and you wouldn't have these problems if you just towed the line and got this kind of education that's artificially, intelligently normative, so that you can be a person who creates these things that we're talking about. And I don't discourage people from doing it. I mean, that's what I did too. I mean, my living has always been writing software, or not always. I changed at some point, but for 20 years, that's what I did. And so I think it's fun, it's enjoyable, it's a wonderful thing to do, and I'm not putting it down in any way, but I'm saying that it goes to what Rob was talking about, being holistic. It's not just holistic in your corporation, but it's holistic in your whole society. And you need to ask the question of yourself, and this is something James would say, about like what you're doing, what you're doing is influencing everyone. And we need to learn to see the value and have respect for those 2/3 of people who don't have college degrees. There's people out there that, in fact, the guy I'm talking about is my tile guy. His brother is a PhD in an endowed chair at a university, but he does tile. And he's every bit as valuable and as important as his brother. Yet we're developing this system. And I want to end with just a great example is Walter White. And now, if you're not familiar with Walter White, he was a chemistry teacher in one of the most popular television, probably the most binge-watched show ever, called Breaking Bad. And what it was is he played a high school chemistry teacher who found out that if he made methamphetamine, he could sell it and get rich. And he did, and he was making millions rather than whatever paltry amount that they pay the chemistry teacher. Now, methamphetamine is a highly addicting, incredibly damaging drug. It's probably one of the most dangerous drugs that exists. And so he was out there wreaking havoc on society, but he was making money. And so if we say to ourselves that the measure of what we're trying to do is making money, then Walter White was a good guy after he started selling methamphetamine. And while he was a high school teacher, he was a bad guy. And I'm going to leave us with that metaphor, but and that's what I'm going to do. I'm going to leave us with that metaphor so we can think about it.
Thank you, Mr. Sharif.
So it's a great discussion, I think, and I just agree with most of the panelists, and I really like the point that has been addressed. So I think robotics and automation is one of the things that the more we become perfect, the more we get the control over some difficult situation, and the more we have the perfection over difficult situation, we can actually explore more. So we can actually reach to the places which is like maybe dream for previous generations. So that's a good advantage. And obviously strategy or policies are very important when we come to this kind of situation, because which is like transformation, right? We are changing from one area to other, or maybe we're changing from one domain to other. So policy and good technology, it's a great combo, and we have to utilize for the development of human society. And I think robotics is the reason we can actually think beyond the universe, or maybe, universe means I'm talking about the think universe, like but we could not dream before, but now it's reality. So I think thanks to robotics and automation and all the people behind it, we can actually reach beyond the thought, or maybe beyond the imagination, and we can bring a lot of perspectives in our future actually. Yeah.
Thank you. Thank you. Thank you. Thank you, everyone, for joining today's sessions. I request everyone next week from Monday to Friday, actually, because last summit we have a lot of speakers. So these 5 days we have our summit on healthcare system, and especially we want to discuss on the future strategies and other things. So I request everyone, so you can join. You have 10-minute slot. You can present your paper or about your organizations. So we will happy to invite every speaker, those who joined today. And beside that, I just want to share that World Talent Economy Forum, why we developing this kind of content, because we want to create good example for the society. We need more hero like you. We need great speakers like you. If our youth communities, they set their goal that yes, I want to be like Mr. Professor David or Mr. Rob or James Sid or Shourab or Professor Donalds, this is ultimately the success. Because when I start my career as a lecturer 12 years before, my professor, he already died, he was dean, Professor Habibur Rahman. He said that teachers' main job is not the reading, like taking care of students, go for the exam and other things, not like that. Their main objective, they had to create some goals for their student, for the youth community, for their people, because this goal actually helped them to do some hard working. They need some dream, they need a good example. Now all of the like movie stars, even sportsmen, politicians, they are the stars, but we need more scholars like you. They should be the example for the society. When they have more example that how they have to like do research, what is the benefit of the research, what is the benefit of the corporate worlds, how they can get access in the corporation, how they can develop the startup, many things we are bringing together. So that's why I request all of our youth community, you can learn from our mentors. They are the real hero, because we are producing more content based on the demand of the youth community. So they are the real hero, and I'm sure if you directly even communicate with them, they will guide you and they will help you for developing your startup, for developing your careers, even any organization, even policymakers. I'm sure they will help each others. And beside that, World Talent Economy Forums, we have our own classroom, as well as we have our research centers, our debate academy. We are working together. So any of our speakers, if you have any plan or anything you want to share with Asia Pacific community, we are ready to help for your projects, and we are open for collaboration. So I request all of the youth community, share our content as much as possible with your government, with your corporations, with your academia. By this way, we will grow. And I'm sure that even Shourab, I think he's from India, he knows that why this kind of content is so valuable for the big communities in India, South Asia, Asia Pacific, developing nations. Because ultimately, I'm also from a very small village of Bangladesh. Only my father, yes, he was a highly educated, but he never said that you have to go to Oxford, you have to go to Cambridge, you have to build up these things. But when I find out my teachers actually create some goal for me, so I do a lot of hard work. So that is my objective from the academic point of views. We want to create more hero like you. So we need more hero, those who join in World Talent Economy Forum, and your discussions, I'm sure it will change millions of lives. It will change, because this is the way actually we set the youth community's goal. Thank you everyone for joining today's sessions, and thank you our honorable speaker for your beautiful contribution for World Talent Economy Forum. So what is the concluding remarks anyone want to share? So you can, Professor David, Mr. Rob, or anyone. Yeah.
One comment I have to build up on something Rob said. One of my interesting stories is I was in a semiconductor fabrication facility in Florida. They noticed that during some shifts, the yield on the chips, the defects, went sky high. But they were really good all other times. They were going crazy. What they found out is when the Atlantic was in high tide, they had defects. When it was not in high tide, the yield was very high. So robotics and AI, you sometimes have to look outside.
Thank you.
And
Thank you,
Sharif,
Mr. Rob. Yes.
my concluding remark is that if you do develop artificial emotional intelligence, I'm willing to be the alpha tester.
Thank you. Thank you.
I'll
Thank you.
get him.
Mr. Rob. Yes.
So recognize that robotics and AI are two of the largest trends that we're currently monitoring this decade. The area is full of opportunity. But like anything else that's fast growing, there will be an awful lot of companies that make it and a lot more that don't. And the difference is probably going to have a lot to do with whether or not the company has been able to analyze the opportunity, find a niche, and then create a beachhead that can be defended. The issue we've got right now in the industry is smaller companies come forward, they get funded, then they get acquired, or they come forward, their IP is stolen, and they get wiped out. So understanding those dynamics when you're looking for a job and getting started is important, because if you're going to work for a company that hasn't protected its IP, or you're going to work for a company that is targeting an area that doesn't seem to have an obvious opportunity. One of the early examples of failure was a robot that was created as a general use robot called Baxter. AI core, $25,000 can be brought in and do everything. And the problem was it was not economically viable. Where they were putting the robot, labor was just substantially cheaper. And so the companies couldn't justify the cost of the robot because labor was so cheap. The post analytics showcased they should have targeted areas that had higher labor cost if you're going to use it as a labor reducer. Therefore, you could justify the cost of the robot. So as you're looking at these opportunities, make sure they're financially well sorted, that the market that they're targeting exists. If it is a proposed market, or a market that hasn't opened up yet, or they just can't really describe who it is that's going to buy the product, go someplace else. You want to go to work for a company that has a well-defined market opportunity, and one that understands the protection of IP is incredibly important. Otherwise, it's going to be a dead end. I'm not saying you won't get experience, and the experience might be valuable, but early on, experiencing a layoff or a collapse can be pretty traumatic, because often early in life, our salary is basically what it is we're living off of, and we don't have much in terms of reserves. So finding a place to intern, to work that has an established market early on is probably going to be a lot safer and a lot less traumatic for you. For those of you that can take the chance and have some financial reserves, startups are a huge opportunity and experience. Just recognize, but about 7 out of 10 of them or more fail, and so you're going to get an experience you probably didn't intend to get. Education, as it relates to an emerging technology area, is sometimes less valuable. Formal education is sometimes less valuable because schools take a while to catch up to the trend. So in an emerging market, I've known an awful lot of people that jumped out of scale. Bill Gates, the example of somebody I knew that just said, I'm going to exit. Computer PCs are coming. If I spend time in school, I'm going to miss the wave. And he made a right decision. But there's only one Bill Gates, and so that kind of opportunity is a bit limited. So as you're going through school, internships are incredibly important. They give you the experience that you need. So when you come out with your degree, you have a better chance of actually getting a viable job. So make sure if you're in school now, if you don't have an internship, that's going to be a mistake as you come back out the back end. It helps you gauge what the industry is doing and helps you position against a job that you're more likely to get, as opposed to coming out and then trying to figure out where it is you're going to go, because by that time it's way the heck too late. So think through that. Best of luck. Huge area and a lot of opportunity for the future. And it's a ton of fun. If it were me, I would be looking at going into areas surrounding simulation, because I think that's going to be the most interesting and most fun near term with regard to both robotics and AI.
Thank you, Professor Donald.
I just want to agree with everyone's been saying, and I want to point out that robotics and AI go beyond the robots and the AI itself. There's the whole idea of how it's used and how it's integrated into the workflow or human life is incredible. It's going to require a lot of people and a lot of thought and a lot of work. For instance, if you're say a venture capitalist or something like that, you're not necessarily going to be building robots, but you're a critical and an important part of being able to make robotics and AI happen. Norbert Wiener said all the way back in the 40s, he pointed out that with the example of truck drivers, if trucks become mechanical slaves and you're competing to drive a truck, what are you competing to be? You're competing to be a slave. And I mean, that's not something that any of us really want to do. And I want to point out that it's very noticeable that when massive leaps in technology happens, it causes huge disruption in society. For instance, in the United States, there was an economy in the South that was based on extremely inexpensive labor because they had slavery. And it was very, and in the North, they became richer and richer because of the industrial revolution that was happening at the time. And there created a huge amount of animosity and ultimately the Civil War. And you can also look at World War I, World War II, and show that part of what happened was these disruptions in technology. So people are definitely unwilling to change. And the whole idea of unions resisting change is, it's a fact. I mean, it's there. But on the other hand, unions are there also for people to be able to collaborate, to be able to join up together. So the ideal union would be the unions constantly changing and adapting to be able to allow people to do collective bargaining. And unions are responsible for a lot of the things that help us a lot in life. So my advice is that, look into yourself, and if you really enjoy calculus and playing with robots, it's simple. And we're back to where you can do stuff in the garage. I mean, there's robotic contests where kids build robots now, high school kids. High school kids are doing all of this. You can do it in your garage. It doesn't require giant plants and facilities. So if that's your interest, you can do that. But if your interest is in human beings and how society works, you can become a manager, work with investment firms, and go into government and go into different kinds of ways that people can work together for the benefit of us all.
Thank you. Shorop.
So adding to all the panelists, I think especially for the South Asian countries or maybe India or such countries, I think we should start inspiring about the STEM education more in the school level. And also we should focus on the research mindset building, because innovation can start from the kids also, from the school students also. So we should not only wait for when we reach up to masters or PhD or something like that. We should start doing research from the beginning, and that mindset could inspire us to deal with maybe topics like robotics or many other things. So that's one of the key points I think I should make it here. And then I think we can start innovating from the very school level. So the growth of the innovation can start from the student level, and it can actually help anyone, not just there are candidates who might not be reaching up to masters or PhD, but they can start innovating from the school level. So that's a very important thing, and they can make the startup or anything, even they don't have the PhD or master. So I think this is one of the most important thing I feel we can start, and we can educate people. Thank you.
Thank you everyone for joining today's sessions. It's really great session for all of us. Thank you, Professor Rob, Professor Donald, Professor David, and Mr. Shorov. Thank you for joining today. Bye-bye and take care.
Thank you.
Bye-bye.